So when I did the video before for this problem, I promised you a second way to think about the substitution. So here's that second way to think about it. We said that if we have an integrand that contains a product, and we can think of some function u, so that one factor in our product is a function of u, and the other factor is the derivative of u, then we can make a u substitution and sort of undo the chain rule to find an antiderivative. So here we said we're going to let u equal cosine of x, in which case du is going to equal the opposite of the sine of x times dx. So the last time through, we said, well, if we isolate the dx in this expression, then we replace the dx in the original integral with that new expression, then we should be able to cancel out any function that still has an x in it, and have a new integral that uses only u. So here's another way to think about it, which can be a little bit faster if you are ready for it. If you've already decided that u is going to be cosine of x, and then you're thinking in your mind, well, that means that part of my integral I'm going to be able to write as e to the u, which means the parts that are left over sine x dx are the parts that should disappear and leave behind du with maybe a constant or a negative. So if sine x dx is what's left in your integral, then you might find it easier to take this expression and isolate sine x dx instead of isolating just dx. So I'm going to multiply both sides by -1, and I'm going to have the opposite of du equals sine x dx. And then if you're ready to make that substitution, notice you have this integral with a sine x and a dx in it. I'm going to replace that part with negative du. So when I went to write my new integral, I would write the integral of e to the u, replacing that cosine x. And when it was time to replace sine x dx, I would replace that with du, negative du. And you can see I've ended up with the same integral as the last time I did the problem. That's just a little bit faster way to think of making that substitution.